In this experimental setup, we have a current value, we have a voltage value, we have intensity as a percentage, we will adjust it, and then by adjusting our current value as 0, we will look at our voltage values, and then as a procedure of the experiment, we will change our wavelength values. Our first wavelength is 472. After making this cable connection, now our current value is approximately 0 and our voltage value is 0.66 and 4. Please record this. After that, let's increase our wavelength value. The second value is 505 nanometer. For 588 nanometer, we adjust our current value as 0, and now our voltage value, measured voltage, is 0.136. And the last one is 611, and then again we will adjust our current value as 0. Last voltage value is 0.095 volts. So our measured values are these. Another important thing about this experiment is our intensity value. Intensity here, light intensity, and here it's given as a percentage value. If I change my light intensity, as you see, voltage value remains same. So actually here the energy is dependent on the frequency of the light, not depends on its intensity. So because of this, we see the same voltage value here.
So to determine the Planck's constant, we need to plot a graph of energy versus frequency, as you know. And to do that, we use Excel program. First of all, what we need to do is we need to convert the wavelength values we noted from our experiment and the potential values that correspond to each wavelength value that we measured during the experiment. And we need to use these values we measured or we noted down to get frequency and energy values. So first of all, let's start with the frequency calculation. To calculate the frequency from wavelength, first we need to convert the wavelength values that are in nanometers to wavelength values in meters. As you see here, we divide each value by 10 to the power of 9 to get the wavelength values in meters. Then in the second step, to get frequency values from wavelength values, we divide speed of light, which is 3 times 10 to the 8 meter per second, by the wavelength values, as you see here, that are in meters. And at the end, we got the frequency values in units of 1/second or in units of hertz. Okay. So we calculated the frequency values. Now we need to calculate the energy value from the potential value we measured during the experiment. To calculate energy value, what we need to do is we actually need to multiply this potential value by the charge of a single electron. So charge of a single electron is around 1.602 times 10 to the minus 19 coulombs. So we multiply that value by the potential value we measured, and we got the energy values in joules. Plot the energy versus frequency graph using the data we calculated for energy and frequency. And as you see, energy values are in y-axis, frequency values are in x-axis. And these are the data we have. We measured and then converted to frequency and energy, as you see here. So what we need to do now, we need to get the slope of this graph we have here. And to get the slope of this graph, we will use the add trend line option of Excel. And we will add a trend line a linear trend line to our data, as you see here. Let me make that a little bit better. You see this black dotted line now represents the trend line to our data, and here we have the line equation for this trend line to our data. This is the linear fit for our data, and we can actually also make this value shown as scientific value, this line equation, so that we can see it better. So here we have the line equation, and based on the line equation, we have an equation such that y equals 6.56 times 10 to the minus 34 x minus this value we have here. Okay, so the slope is this value before the x, as you know, and that value, this slope value, is the Planck's constant we determined using this experiment. Considering that Planck's constant is 6.626 times 10 to the minus 34 joule second, our value is very close to the accepted value of Planck's constant.